Okay, today we're going to talk about magnitudes and directions of vectors. So, magnitude is the length of the vector, and we use Pythagorean theorem to help us figure out this length. Okay, so Pythagorean theorem, that's a squared plus b squared equals c squared, right? And where hypotenuse is the c squared. Okay, and in the x direction, this is 3 units, and in the y direction, goes up and down, right? That is 4 units. Okay, so if I want to find this length, if I know this is 3 units and I know this is 4 units, notice how from this point it's going 3 units positive and 4 units up, so that's positive. So if I'm using Pythagorean theorem, I could say 3 squared plus 4 squared equals c squared. Okay, so 9 plus 16, c squared, 25, c squared, c equals 5, right? Okay, so anyways, but what we've got here is this is important. We've got this angle. It's called angle alpha, right? Okay, we've got some angle here. And if I want to find the angle, we can do, if I remember, so TOA, we've got the opposite side here. We've got the adjacent side here. And so if I've got opposite and adjacent, I'm going to use tangent. So tangent alpha equals opposite over adjacent. We could also find this angle with 4 over 3, opposite over adjacent. And if I use my inverse button on my calculator, I end up with 53.1 degrees. Okay, so let's do a problem that talks about magnitude and direction. Okay, so if I look at this first example here, you're told that you're going at a bearing of 130 degrees, and it's going to go 15 meters. So we're starting right here, and we're going to go 15 meters. This length here is 15 meters. Okay. Now, okay, notice here they've already written 40. Why did they write 40? Because, you know, all the way around from here to here. So north is always pointing at 0 degrees. North is always pointing up. So if you're going 130 degrees, you're going to go counterclockwise. Okay, you're going to go counterclockwise this direction, and so you know that this is 90 degrees from here to here, right? So then I can do 130 minus 90, and I know that this angle here is going to be 40 degrees. Okay. Okay. So now vectors, you know, there's the x direction. Okay, I'm going to try to use the same colors that I did on the top. So the x direction, and we've got a y direction. Notice how if I'm going this way, the x direction is going to be positive, and here the yellow one is going down, so that's going to be negative. Okay, so how did we get these values here? So if I'm just going to redraw this. Okay, if this is 40 and this is 15, and I want to find, this is the x direction, right? Let's just call it x, right? So according to this angle, that is adjacent, right? Here we have the hypotenuse. So if I've got adjacent and hypotenuse, I'm going to look up here and I'm going to use cosine. So I can say cosine 40 degrees equals adjacent over hypotenuse, x over 15. And we want to find x to go here. So if I put this over 1, cross multiply, I get x equals 15 cosine 40 degrees. And that's how they got this value. Okay, that's how they got this value here. Now, I'm going to do this to get this value here. So, if this is 40 degrees, this is 15, we want to find the opposite side. We're going to use sine, because you know sine of the angle is equal to opposite over the hypotenuse, right? Okay, so we've got sine 40 equals the y value, because it's opposite, over 15. And if I want to find the y value, I could put this over 1 and cross multiply, and I get y equals 15 sine 40. Okay, and once again, since I said this is going down, that's why we have that negative. Okay, so now to figure out this length here, I can use my calculator. And so if I do 15, cosine 40, make sure you're in the right mode. We're doing this in degrees, right? So my mode, I need to be in degrees. Okay, so 15 cosine 40, I get 11.49, so they wrote 11.5. 15 sine 40, and we get 9.64. Don't forget to make that negative. And so we can write it in component form, or we can write this in vector form. Okay, so this is vector form, and this is component form. Okay, and we did that in our last lesson. Okay, so how do we find the magnitude and direction of vectors? So you may want to hit pause. So magnitude can be found using Pythagorean theorem, and the direction can be found using angles and trigonometry. You might want to hit pause to copy this down. Okay, next page. Okay. All right, a boy walks 5 kilometers with a bearing of 45 degrees, and then 8 kilometers with a bearing of 120 degrees. Okay. I'm going to do the drawing over here on the left. Okay. So, starting off here, remember north is always pointing up, bearing of 45 degrees. So that means I'm going to go from north, I'm going to go clockwise 45 degrees. Okay? And I'm going to go 5 kilometers. Okay? Then I'm going to stop. And then I'm going to go 8 kilometers at a bearing of 120 degrees. So here I've got north. I'm going to go 120 degrees from there, and I'm going to go 8 kilometers. Okay. Now, if I break this up into If that's 90 degrees, then I can do 120 minus 90, and I can figure out that other angle, and it looks like it's going to be 30 degrees. Okay. Now, if this north arrow is going up here, I can draw a dotted line, and that's going to be south, right? So this makes a 90-degree angle. If that's 30, this is going to be 60 degrees. And also, if this is 45 degrees here, this one here is also 45 degrees because they're alternate interior angles. So that one's going to be 45 degrees. So together, this is going to give me a triangle. We know this length is 5. We've got 45 plus 60, which is going to give me 105 degrees. And then we know that side is 8. Okay. So show this information on the diagram. Here we do. Question A. Okay. So 5 kilometers, bearing of 45 degrees, then 8 kilometers, bearing of 120 degrees. Okay. Use the cosine and sine rules to find the distance and the bearing from his starting point to the end of the walk. Okay. So I'm just going to call this x right now. And the cosine rule, if you can recall from your formula packet, the cosine rule is, we're trying to find the length, right? So c squared equals a squared plus b squared minus 2ab cosine c. So we're going to say x squared equals 5 squared plus 8 squared minus 2 times 5 times 8 cosine 105. You might want to hit pause and rewind to see that. Okay. Remember, this x is the one that's across from the 105. That's how I know that the 5 and the 8, those values here on the formula are the ones that are, the a and the b are the ones on either side of angle C. Okay. So then I plug it into my calculator. I get x squared equals 109.7. Square root of that, x equals 10.474. Okay, so that's that length. So this is the distance of x. Okay, now we want to find the we need to find this angle, right? We need to find that angle because we want to find the distance and the bearing from the starting point to the end of the point. So we want to find, eventually we want to find this whole angle here, the bearing from the starting point to the end of the walk. So this angle here is the whole bearing. But first we just need to find this angle here. So I'm going to use the sine rule. So using the sine rule, I can write this as 8 over sine theta equals 5 over, oops, no, my mistake, equals 10.474 over sine 105. Okay, I can cross multiply. I get sine theta equals 8 sine 105 over 10.474. Plug all that into the calculator, and then I get the angle is 47.5 degrees. Okay, and so now I want to find the bearing. And remember, we already know this part right here is 45 degrees. So I can say the bearing equals 45 plus 47.5, right? So that green angle plus this angle here to find the bearing. And so then I get my bearing is equal to 92.5 degrees. Okay. Now, this works really well if you know the cosine rule and sine rule. We're going to do the exact same thing now for the rest of this handout, but using vectors. Okay, so we're going to write the displacement 5 kilometers on the bearing of 45 degrees. So the first thing I'm going to do, we know this distance is 5. So like we did before, 45 degrees. This is opposite. So we're trying to get a vector. Remember, this is the x and the y, right? Okay, let's find x first. So we've got the hypotenuse, and we've got the opposite. And I always write SOHCAHTOA on every page just to help me figure it out. So what did we have? We've got opposite and hypotenuse. Opposite and hypotenuse means we're going to use sine. So I'm going to say sine 45 degrees equals, I'm going to call that x, equals x over 5. Because sine equals opposite over hypotenuse. So now if I want to find x, x equals 5 sine 45 degrees. Okay, now to find y, this value, that's adjacent, right? So I can say that adjacent and hypotenuse means we're going to use cosine. So cosine 45 equals adjacent over hypotenuse. So I'm just going to call this y, right? So adjacent over hypotenuse, y over 5. And then if I cross multiply to get the y value, we get y equals 5 cosine 45. Okay, so this first vector is 5 sine 45 degrees, and the y value is 5 cosine 45 degrees. Okay, now I've got this other triangle here. 8 kilometers with a bearing of 120. Okay, 8 kilometers with a bearing of 120. So as we said, if this is 90 and it's 120 degrees, this is going to be 30 degrees. Okay, so we've got opposite and hypotenuse. We're going to be using sine, so I can say sine 30 equals opposite. I'm going to call that y over hypotenuse over 8. So then I get y equals 8 sine 30. And then for the x value, I can say we've got the adjacent. So for the x, oops, messed up with my coloring. Man. Okay, so with the adjacent and hypotenuse, we're going to use cosine. So we've got cosine 30 equals x over 8. So we know that x equals 8 cosine 30. And so this is my other vector is 8 cosine 30 and 8 sine 30. Okay, so we're going to write this in column vectors where the first component indicates the displacement east. That's this one here. And the second vector is the displacement north. Okay, so now one thing here. Notice if I'm going 120 degrees, I'm going down here. So this one here needs to be negative. Okay. All right. So you're going to use this answer to find out how far east and how far north we've gone from the starting point to the end of the walk. So to find east, we're going to use the x values. We're going to use this and this. So to find east, for east, we're going to do 5 sine 45 plus 8 cosine 30. And that tells us how far east we go. If I plug that into my calculator, I get 3.5355 plus 6.928. And we get 10.46 east. Okay, because we're going this way and then we're going this way. Right. Now, east is left and right. Left and right I'm using blue. Okay. Okay. Then north and south, we've got, that's up and down. Up and down I'm using yellow. So north and south, we've got 5 cosine 45 minus 8 sine 30. And then we've got, so if I plug that into the calculator, I got 3.5355 minus, plug that into the calculator, I get 4, and I get negative 0.46447. Okay, so, and that is, so it's a negative value north. So I'm really going south, but okay. Okay, so hence, give the final resultant in a column vector form. So I'm gonna, my x direction is 10.46, and my y direction is negative 0.464. Okay, and so you're going to use this answer to find the distance and the bearing from our starting point. So in my x direction, and that is my y direction. So in the x direction, I've gone 10.46. In the y direction, I've gone negative 0.464. Okay, this is a long distance. This is kind of small, right? So we're going to find the hypotenuse, and this is going to be very close to the same length as there because this distance is so tiny. So using Pythagorean theorem, I'm going to say 10.46 squared plus negative 0.464 squared equals x squared. And we end up with x squared equals 909.6 0.27. One of the mistakes I saw somebody make in class today was when you've got a negative number squared, that's going to give you a positive answer. Okay, so if I've got a negative number squared, clear, negative 0.464 squared, the calculator doesn't know what you're trying to do, and this is going to give you a negative. But what you should have done was negative 0.464 close parentheses squared. This says this negative number times the negative number gives me positive 0.2. When you square it, you're always going to end up with a positive answer. Okay, so be careful right here. Okay, so this distance is 10.47. This is our distance. And you're going to see that this distance matches what we did in part B. And if I want to find this angle, I know this is opposite, right? This is the adjacent, and I can use tangent. So I'm going to call it theta. So I can say tangent theta equals opposite over hypotenuse. So 0.464 over the adjacent 10.46, and then I get tangent theta equals 0.04436, and I do inverse tan on my calculator, and I get theta equals 2.5 degrees. So if I think of my direction, remember my triangle looks like this, right? So I've got this angle, and hold on a second. Let me just redraw this. I've got my vector, and I'm going this direction here is 2.5 degrees, and we know this is 90 degrees. So together, the bearing is 90 plus 2.5, which gives me 92.5 degrees. And that is the same answer for the bearing that we got up here. So some of you are thinking, oh, I know how to do law of sine and law of cosine, blah, blah, blah. But this vector way is going to be much easier when we start getting much more complicated. For example, in the last question on the page, we go this way, this way, this way, this way. You can't do this question with law of sine. You have to use vectors because there's so many different directions that you're going. Okay, so the next ones I'm just going to kind of talk through because that's what I'm going to do. Okay, so we've got a sailboat going 60 miles with a bearing of 30 degrees. So let's zoom in so you can see what we're doing. Okay, so 60 miles at a bearing of 60 degrees or 30 degrees, followed by 90 meters with a bearing of 160 degrees, followed by 40 meters at a bearing of 280 degrees. Okay, let's do one at a time. Okay, if I'm going 30 degrees, 60 meters, so from this point here, north of 0, right? So 30 degrees means I'm going this way. So if I want to find my x direction here, I've got opposite and hypotenuse. So if I'm using opposite and hypotenuse, I'm going to do sine, aren't I? So I'm going to say sine over 60, opposite over hypotenuse, sine 30, opposite over hypotenuse, and then I rearrange this and I get opposite equals 60 sine 30. Okay, and then I do the same thing, and then the y value is going to be 60 cosine 30. Okay, the next one, 90 meters, a bearing of 160. So if it's a bearing of 160, then if that's 90, then it's going to be going down 70 for 90. If this is going to add up to 160. Okay, so in the x direction, it should be positive, right? And in the y direction, it's going down. So I'm going to, since it's going down, this is going to be negative. Okay. I use my triangles again, and I've got cosine 70 and sine 70. You might want to hit pause to think how I got these values. The last one is a little bit tricky. I'm going at a bearing of 280 degrees. So remember, if this is north, then this way is going to be 90 degrees. Going due south is 180 degrees. And if I'm going all the way west, that's from here to here is going to be 270. And if I'm going 270, then 80 is just an additional 10 degrees more. Okay. So here's my angle for the other one. So we got 10 degrees. We got opposite and adjacent. So if I've got adjacent and hypotenuse, I'm going to use cosine. And notice it's going to the left, so that makes it negative. And then it's going up, so I got opposite and hypotenuse, so I'm going to do sine. And notice it's going up. Okay. So now I'm going to add these values together, and then I get this. Okay. So if I want to find the distance, which is also called the magnitude, then I can use Pythagorean theorem or the distance formula. Right. So we've got the distance formula in this packet here. Okay. So we've got this one squared plus this one squared, and then we find the distance is 33.4 from the starting point. Okay. So for the next definitions, you might want to hit pause. How can you represent vectors? Think about how you would attempt this question if they asked you to use sine and cosine rules. You can't draw a single triangle for the cosine rules because there's 3 different components. Okay. How can you represent vectors? So vectors are represented using arrows. The heads of the arrows tell us the direction. The length of the arrow tells us the magnitude. The magnitude is equal to distance. Okay, which representation is easier to use to find the result? Component form is the easiest one to use. Okay, that's when you've got your x value and your y value, like that. Okay. How do you find a particle's displacement from its starting point if given its successive individual displacements? So you're going to represent each displacement as its own individual vector. Then you're going to add up all the vectors together. Then you can find the magnitudes and bearing of the resultant vector. What is the resultant vector? The resultant vector is when you add 2 or more vectors together. Okay. Okay. I'm going to let you check your answers. This plus this plus this gives me this. And then I used the distance formula to figure this out. Okay, if I go over 4 and up 4, well, I know that's going to be a 45-degree angle. Here, add 5 and negative 6, I get negative 1. Add 2 and negative 4, I get negative 2. I use the distance formula, so 1 squared plus negative 2 squared, we're going to get the square root of 5. So the magnitude, the length of my vector is 2.24. So we know from this point we're going to the left 1 and down 2. So I'm going to have tangent of theta equals 2 divided by 1. And so if I do inverse tangent 2, I'm going to get 63.4 degrees. Okay, now this angle here is 63. Now this question's a little different. This didn't say bearings, did it? It says from the direction I. So if I've got a two-dimensional grid, this is I, the direction of I, and this is J. So if it's from the direction I, and I'm going this way, they're asking you to go all the way here, and you know that this portion right here, we just figured out this little bit is 63.4. That part right there. Right? Well, if this green part is 63.4, this half of the circle is 180. So to figure out the direction from I, so the direction from I so the direction from this orange line going all the way over here is 180 plus 63.4. That gets us this answer here. Okay. Okay. Check your answers. Question 2 is pretty important. Verify that this is equal to this. So this is your x value, your y value. When you see this here with the lines like that, that means find the distance or find the magnitude. Okay, so 48 squared plus 20 squared, add those together, take the square root, you get 52. Now here we're going to do 12 squared plus 5 squared, add those together, take the square root, I get 13. But I'm multiplying it by 4, and then I get 52 also. Oh my goodness, those are the same. If I multiply the 4 times 12 and the 4 times 5, I'm going to get 48 over 20. So you can factor out the common factor and then find the distance, use the distance formula to find this magnitude and multiply the factor. So using that method, I could say, okay, 18 and 24. I know I can factor out the 6. Okay, now I can use what I know about the distance formula. So 3 squared plus 4 squared, I'm going to get 5 here. So the magnitude of this vector is 30. Here I can factor out the 10. Negative 3 squared plus 4 squared. We know this magnitude is going to be 5. The length of this vector is 50. Here I factor out the 7. And then I do 4 squared and 3 squared. We know this magnitude is going to be 5 from what we just did over here. And so we have 7 times 5, 35. Okay. These next ones I'm going to let you try on your own. Hit pause. Okay. Last page. Hit pause. And the very last one. Hit pause. I hope this helps.